Hi, we are from Group 7 are going to present our structural analysis project. For the introductions, a load-bearing structure with many vertical, horizontal and diagonal elements is known as a truss bridge. These are frequently designed in triangle shape to efficiently distribute forces through a structure in order to enhance the building strength while using minimal materials. A truss is a collection of separate elements that function in tension or compression and work as a single unit. An attention member of a truss bridge is subjected to forces that draw outward at its end. These members are often individual metal elements such as bars or rods, even on a wooden truss bridge. And this project is essentially study the deflections of the truss and the load that can fit the bridge after undergoing the calculation using manual and software calculation. For manual calculation, we are using joint method and alternative method. For the software, we are using LinPro applications for the calculation. For the objective, the first one is to apply our knowledge on the different type of truss, then to determine the internal force and calculating the deflections of a structure, and to find the force and deflections with our own assumed load and one unit load, then to monitor the differences between the software and the manual calculation.
Hi, my name is Atika binti Fitri, number matrix AF2039, and I will present for design and layout together with literature review parts. For our design, you can see from our slide, the design of our bridge has total length of 54 meter and total height of 10 meters. This design we have been modified to its our calculation. Next, we calculate the number of redundant using the formula m plus r minus 2j, where m 26 r 3j 14, and we substitute the value, we got 1 degree of determinacy for our bridge. Next, we calculate the determinacy criteria for our bridge. We compare the m plus r with 2j, and we can determine our bridge that it is over stiff truss with statically indeterminate. Next, for the literature review, our bridge layout was inspired by the Santa Ana River background truss bridge located at Santa Ana, Orange County, California, United States of America. This bridge was closed, actually, because of the age structure, but it will have been a rumor that this bridge will be reconstructed back for the new structure to get the more strong and stable bridge. And this bridge was designed using two span phagon truss with total length of 82.05 meters.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ilyani Batimat Anwar. My matrix number is AF200033. For the methodology, first, we sketch the bridge. Second, we choosing one of the proposed bridge design. Next, we using the LinPro to create the design and implement load. And then we start manual calculation. Next, we compare and discuss the result.
My name is Nisma Wayindi binti Matani and my metric number is AF2012. So today I will present about the result and the analysis. So this is the analysis of the internal forces of the bridge with 109 kilonewton load, which is we calculated manually by using the method of join. And then this is the analysis of the internal forces of the bridge with 109 kilonewton load by using the software, which is LinPro 27 software. So this table shows the comparison between the software and the manual calculation for the internal forces for all the members. In this table, we also calculate the difference between the LinPro and the manual calculations, and then we find the percentage difference. So the average percentage difference of the bridge is 4.48%. Hence, The difference percentage of the load between the LinPro 27 software and the manual calculation is 4.48%.
Assalamu alaikum. I am Ala Rakib Ali Muhammad. My matric number AF190273. Today I will present to my part discussion the safety of the trusses. A highly efficient bridge, according to the efficiency equation, is one that can withstand a high load while weighing little. We designed the bridge to carry as many loads as it can. We learned eventually key design elements and features throughout the project: height, reinforcement, distance between members that could affect the structural integrity of the bridge to achieve a high efficiency. After analyzing the load distribution in the bridge, the different percentage of the load between the Lean Pro 27 software and manual calculation is 4.48%. We can say that design is safe withstand high loads. Aside from that, we discovered that the braid's workmanship is the most important and determining aspect in its efficiency. Any little unfinance might cause the weight to be transferred infinitely, resulting the bridge low efficiency. We try to keep our craftsmanship consistent across all models by designing certain responsibilities to specific people. Proper way of achieve and consistency of going the members are important to ensure connection are strong.
And lastly, for the conclusion, the redundant member LE was considered as X. Using the formula of F equal to F prime plus X mu, the X value from the applying load of 109 kN is negative 212.615 kN, while from the virtual 1 unit load was determined as negative 62.105 kN. The average percentage difference of the load between the LinPro 37 software and manual calculations is 4.48%. Both types of calculation are able to calculate deflection and internal force of the truss. We are able to see the using of software calculation is more accurate than manual calculation. This is due to the features in the LinPro software being more easy to conduct. In conclusion, both of the calculation are able to obtain the value for force and deflection. That's all from us. Thank you.